Today's #1 most urgent vulnerability is CVE 2026-64849 in MLflow. And it earns that spot for a simple reason. It combines a critical 9.3 CVSS score with CISA Known Exploited Vulnerabilities status. In plain English, this is a flaw where an unauthenticated request to an MLflow webhook test endpoint can potentially make the MLflow server reach places it should never expose, including internal services or cloud metadata services, and return response details. That is exactly the kind of bug that turns an externally reachable application into a window into private infrastructure. This is the Daily Ranked CVE Brief, What to Patch First, ranked by Real Exploitation Signal, CISA KEV, First EPSS, and CVSS every day. And for today, the patch first answer is MLflow. MLflow is described by NVD as an open-source AI engineering platform for agents, large language models, and machine learning models. The vulnerability is classified as CVE-2026-64849, Server-Side Request Forgery, or SSRF. SSRF means an attacker does not directly connect to the internal target. Instead, they convince a server, here, the MLflow server, to make a request on their behalf. The NVD description is specific. Before version 3.15.0, the unauthenticated post endpoint at /API/2.0/MLflow/webhooks/ID/test calls a URL validation function only for the original URL. But the delivery code follows redirects and re-resolves the hostname without pinning the already validated address. That gap can allow requests to end up at internal or cloud metadata services, with response status and response body returned. Verdict: this is a critical, unauthenticated, network-reachable SSRF with a serious data exposure path. The most important CVSS signal is reachability. The vector says network attack vector, low complexity, no privileges required, and no user interaction. That means defenders should assume that if the vulnerable endpoint is exposed to an untrusted network path, an attacker does not need an account and does not need to trick a user into clicking anything. The second key signal is impact. Scope is changed and confidentiality is high. Scope changed means the consequence can cross a trust boundary, from MLflow into other services the server can reach. Integrity is listed as low, availability as none, so this is not primarily a crash bug. It is primarily about using MLflow as a path to information that should remain private. The reason this is not just a theoretical bug is CISA KEV status. CISA's Known Exploited Vulnerabilities catalog is a strong signal that exploitation has been observed in the real world. We are not naming campaigns, malware, or attacker groups here because none are provided in the data. But KEV status changes the response posture. This is no longer a vulnerability to schedule casually. It is a vulnerability to triage immediately. MLflow deployments can be connected to model development, experiments, automation, credentials, data stores, and cloud infrastructure. The vulnerability description specifically calls out internal services and cloud metadata services. If an attacker can cause the server to fetch those resources and return the response body, the risk is not limited to the MLflow application itself. The server's network position becomes part of the blast radius. Conceptually, the attack path is about a mismatch between validation and delivery. The application validates the original webhook URL, which is the right instinct. But then, during delivery, redirects are followed, and the hostname is resolved again without pinning the address that was validated. That matters because a URL can look acceptable at the first check, then lead somewhere else later through redirection and name resolution behavior. From a defender's point of view, the important issue is not the exact payload. It is that the MLflow server may become the requester. If MLflow can reach internal-only addresses, service control planes, or cloud metadata services, then the attacker may gain a read path through MLflow. The NVD description says response status and response body can be received, which turns the issue from blind probing into possible data retrieval. Start by inventorying MLflow. Find production, development, research, and lab instances, because AI and machine learning platforms are often deployed outside the usual application inventory. NVD states that versions prior to 3.15.0 are affected and that the issue is fixed in 3.15.0. But you should still confirm against the vendor advisory and your package source before closing the ticket. Next, Check whether the MLflow service is reachable from the internet, from broad internal networks, or from untrusted users. The endpoint called out is the unauthenticated webhook test endpoint under the MLflow API. You do not need to run exploit traffic to assess exposure. Determine whether that route is accessible, whether authentication or network controls sit in front of it, and what outbound destinations the MLflow host is allowed to reach. Exposure is highest when inbound access is broad, and outbound access is permissive. The primary fix is to update MLflow to version 3.15.0, the fixed version named in the NVD description. If you cannot patch immediately, reduce exposure while the upgrade is being prepared. Restrict access to MLflow, so only trusted users and networks can reach it. Put the service behind appropriate authentication and network controls where applicable. Limit outbound network access from the MLflow host to only destinations it truly needs for normal operation. In particular, treat access to internal services and cloud metadata services as sensitive and block unnecessary paths. Review webhook functionality and disable or restrict it if it is not required. Finally, after patching, keep the network hardening. SSRF bugs are common enough that egress controls should be treated as a standing defense, not only an emergency workaround. For detection, focus on the behavior described in the vulnerability. Review MLflow application logs, reverse proxy logs, API gateway logs, and load balancer logs for post requests to the webhook test endpoint, especially from unauthenticated or unexpected sources. Compare destination patterns against normal webhook usage. Normal should look like known, approved webhook endpoints used by your teams. Suspicious behavior may include destinations that are new, rare, rapidly changing, redirect-heavy, or associated with internal-only naming patterns. On the network side, monitor outbound connections from MLflow hosts. Pay attention to attempts to reach internal services, cloud metadata services, or destinations outside the expected allow list. Also look for responses where webhook tests return unexpected response bodies or status patterns. Detection will be strongest when application logs and egress telemetry are correlated around the same request window. Bottom line, CVE 2026-64849 is today's #1 ranked CVE because it is critical, unauthenticated, network reachable, and listed by CISA as known exploited. The weakness is CWE-918, server-side request forgery, in MLflow before 3.15.0, involving the webhook test flow and redirect handling. The practical risk is that MLflow can be used as a bridge to internal or cloud metadata services, with response details returned. Patch to the fixed version, restrict access, and tighten egress from MLflow hosts. If this helped you prioritize the day, subscribe to the Daily Ranked CVE Brief, What to Patch First, ranked by Real Exploitation Signal.